Okay, these are notes on 6-6 Systems Applications Day 1 notes. I'll go ahead and put 6-6 in the corner so you know there's 6-6 notes. Okay, so what we're doing here is we're applying systems of equations. And we have these word problems that we are going to write the equations for, and then we're going to solve based on what the question's asking. So number 1, 3 lemon cream plus 2 fudge cookies have 400 calories. 2 lemon creams plus 3 fudge cookies have 425 calories. So how many calories are in each kind of cookie? Well, our first sentence is stating one of the equations. So we're going to write that out. So we have 3 lemon creams. So I'm going to use 3 and L for lemon cream. Plus, that's going to be addition, 2 fudge cookies. So I'm going to use 2 in the variable F for fudge. Have 400 calories. That verb have means that's our equal sign, and it has 400 calories. Our second equation is going to be our second sentence. 2 lemon creams plus 3 fudge cookies have 425. So I'm going to write that out in an equation. So we have 2 lemon creams plus 3 fudge cookies equals 425 calories. Okay, now strategies to solve this one. We have 3 different methods. We have graphing, we have elimination, and we have substitution. And I see that my equations are in standard form, so I'm going to use the elimination method, and I'm going to use the elimination with multiplication. I'm going to go ahead and cancel out my lemons. I have to find both of them anyway, so I like to work with the numbers out in front. My least common multiple is going to be 6, so I am going to have to multiply both equations in order to cancel them out. I have to multiply the top equation by 2 and the bottom equation by 3 so that these two coefficients become the number 6. They are both positive, and in order for them to cancel out, I have to have a negative. So I'm going to make my top equation negative. It doesn't matter which one you make negative. You could easily make the negative 3. Okay, now I'm going to multiply those out, and I am going to get negative 6L minus 4F equals negative 800. And I'm going to get 6L plus 9F equals 1275, 1275. Okay, so now that I have one of my variables ready to cancel out, now I'm going to add my two equations together, and that's going to cancel out my lemons. So negative 4 plus 9 becomes 5F, coming back up here to the top, and 1275 minus 800 is going to equal 475. Then I'm going to divide by 5 because I want to find out how many calories each fudge cream has. So my fudge cookies have 95 calories apiece. 95 calories. Okay, well the question asks how many calories are in each kind of cookie. So I've already found my fudge cookies. Now I need to go back and find my lemons. Doesn't matter which equation you use. I'm going to use the first one. So I'm going to have 3 lemons plus 2, and I know my fudge cookies are now 95 calories. Equals 400, and then I just solve for L, so I've got to multiply. 2 times 95 gives me 190, and that equals 400. And now I have a two-step equation. I'm going to subtract 190, so when I get L by itself, and I get 3 lemon creams are going to equal 210 calories. Then I'm going to divide it by 3 to find out how much each lemon cream equals, and each lemon is going to be 70 calories. Okay, I've now found how many calories are in each cookie. Okay, number 2. The number of calories in a piece of pie is 20 less than 3 times the number of calories in a scoop of ice cream. And the pie and ice cream together have 500 calories. How many calories are in each? Okay, so this is going to be similar. My first equation says the number of calories a piece of pie, so I'm going to use P for pie, and that is 20 less than, so this is another turnaround word that we had at the very beginning of the year, 3 times the number of calories in ice cream. So I have 3 times the number of calories in ice cream, less 20. So I'm going to subtract 20. That turnaround word makes it flip around. The pie and ice cream together, so pie and ice cream together equal 500 calories. Okay, well this is set up. I have one of the variables solved for already. I've got p, and that equals 3i minus 20. So what I'm going to do is I'm going to replace p with 3i minus 20, and then I have the plus I, and that's going to equal 500. So this is using the substitution method. I am replacing p with 3i minus 20. Now from here, I only have the variable I, so then I combine like terms, and I get 4i minus 20 equals 500. And I'm going to solve for I, so that means I need to do add 20 to both sides. And I'm going to come back up here. So I have 4i equals 520. And divide by 4. And the ice cream calories is going to be 130. Okay, so the ice cream has 130 calories. Now I need to find what the pie is. So pi is equal to 3 times the 130 minus 20. So I'm going back and using substitution again. This time I'm substituting for the I so that I can find the pi. So p equals 390 minus 20. And subtract, we get 370. So the pie has 370 calories. So how many calories are in each? We answered that question. Ice cream has 130 calories and pie has 370. Moolah has 24 coins that are all dimes and quarters. The value of the coins is $3.75. How many dimes and how many quarters does Moolah have? Okay, that is bolded and underlined because those are going to be our variables. We have dimes and quarters. So we have dimes and quarters, and there are 24 of them. Now, the value of the coins. Well, the value of a dime is 10 cents. So I have 10 cents per dime. And the value of a quarter is 25 cents. So I have 25 cents per quarter. And then we have $3.75. Okay, so here is our system. A lot of people get intimidated when they have the decimals or fractions in there. So what I'm going to do is I'm going to go ahead and get rid of those by multiplying 100. Our cent value is 1/100th. So to get rid of the decimal, I need to multiply my entire bottom equation by 100. So I still keep the dimes and quarters equals 24, and then this is going to make this 10 dimes and 25 quarters equal $375. Okay, so that eliminates our decimals that we have. And I just use the place value. These are all in the hundredths place, so I can multiply by 100. Okay, so now I can look at my equations and I can see probably elimination is going to be the best way to work with this. So I'm going to take my dimes and quarters equals 24, and I now have 10 dimes and 25 quarters equals 375. And I can do that because it's equivalent. As long as I multiply everything by the same number, I can get an equivalent equation. But I'm going to multiply the top equation by negative 10. So I get negative 10 dimes, negative 10 quarters, equal negative 240. And then I have the positive 10 dimes, the positive 25 quarters, and that's going to equal the 375. And now I'm ready to add my two equations together because I know my dimes are going to cancel out. And I'm left with 15 quarters equals $135. So 15 quarters equal $135. I'm going to divide by 15, and my quarters equal 9. So that means I have 9 quarters. Well, then I have to find out how many dimes do I have. Well, My dimes and my quarters added up to 24, so I'm going to subtract 9. So I have in dimes 15. 24 minus 9 is 15, so I have 15 dimes. Number 4, number of girls at Smith High School is 180 less than the number of boys. If there are 1,250 students altogether, how many girls are there? Okay, well, girls. Girls is, that's another turnaround word. So that means it's the number of boys minus 180. And then girls and boys together number 1,250. Okay, so in this case, since I have G already solved for, I'm going to use substitution. So instead of writing G, I'm going to write B minus 180, and then I have the plus B equals 1,250. Then from here I'm going to combine like terms. I have 2 B's minus 180 equals 1,250. I'm going to add 180. And my 2 boys equals 1,430. I'm going to divide by 2. And the number of boys equals 715. Okay, the question didn't ask how many boys are there. The question asked how many girls are there. So I'm going to plug that back in. Girls equal 715 minus 180. So that gives me the number of girls is 535. So this is our actual answer, 535. Okay, number 5 should be pretty easy. It's pretty straightforward. The sum of two numbers is 90. You can use any two variables you want. I'm going to use x and y. So sum means I'm adding them together to equal 90, and difference means I'm subtracting them to equal 18. I see off the bat, since I have a positive y and a negative y, that I'm going to use elimination, and this time I don't have to multiply. I can just go ahead and add the two equations together, and that's going to equal 0. So I get 2x's equal 108, and then I'm going to divide that by 2. So I have to find both numbers. So my first number is going to be 54. So one number is 54. And then I'm going to go back to my first equation. 54 plus y is going to equal 90. So now I'm going to find my second number. I'm going to subtract 54. And y is going to equal 36. And those are my two numbers. And I used the elimination method. Okay, next page. The width of a rectangle is 4 inches less than its length. The perimeter is 112 inches. Find the length and the width. Okay, so it says my width is, I have less than, so I have that turnaround word. So that's length minus 4. And then it tells me about perimeter. Well, you have to think back to geometry, and we have it on our formula chart. What is perimeter of a rectangle? Well, that's 2 lengths plus 2 widths, and that equals the perimeter, and in this case they tell us the perimeter is 112. So in this case we're going to use substitution because W is already solved for. So I have 2 lengths plus 2, and here's where I'm going to substitute in. Instead of W, I'm going to write L minus 4. Okay, so there's my substitution part, and that's going to equal 112. Okay, from this point we're going to need to distribute the 2 to the L and the negative 4. So I get 2L plus 2L minus 8 equals 112. I'm going to combine like terms because I've got 2 L's here and 2 L's here, so that gives me 4L minus 8 equals 112. And I'm going to add 8 to both sides so I can get L by itself. So now I've got 4L equals 120. And then I'm going to divide by 4, the last step, to get L by itself. And my length is going to be 30. Okay, so we know the length of the rectangle is 30. So the width, we're going to use substitution again. It's going to be 30 minus 4. and the width is going to equal 26. So now we have both the length and the width of our rectangle. Okay, number 7 is similar. The perimeter of a rectangular garden is 312 feet. So again, 2 lengths plus 2 widths equal 312. If the length is 6 feet more than 5 times the width, okay, again I have a turnaround word. So that means I'm going to flip those two phrases around. This time I have the length is 5 times the width plus 6 more. So again, substitution looks really good here. So I'm going to plug in 2, and then I'm going to substitute in for the length, 5w plus 6, and then the rest of my equation plus 2w equals 312. I'm going to have to use the distributive property. So I get 10w plus 12 plus the 2w equals 312. And then we combine like terms. I've got a 10w and a 2w, so that combines to 12w plus 12 equals 312. I'm going to subtract 12 from both sides to get w by itself, and I get 12w equals 300. And then I'm going to divide by 12, and 300 divided by 12 is equal to 25. So my width is going to equal 25, and I'm going to go back and find my length. Okay, my length is going to be 5 times 25 plus 6. So the length is going to be 125 plus 6, and the length is going to be 131. And now I have both my length and my width. Number 8, the Math Club and Science Club had fundraisers to buy supplies for an after-school event. The Math Club spent $315 buying 60 cases of juice and 15 cases of bottled water. The Science Club spent $291 buying 48 cases of juice and 25 cases of bottled water. How much did 1 case of juice cost? Okay, so we have 60 cases of juice, J for juice, and 15 cases of bottled water, and we use W for water, and they spent $315, and that's the Math Club. Then they have 48 cases of juice and 25 cases of water, and they spent $291. Now they want us to find juice. So this is in standard form, so I'm going to use elimination method, and I want to eliminate my W's because I just want to find juice. I don't need to find both of them. So actually my least common multiple between 15 and 25 is going to be 75. So that means I need to multiply the top equation by 5 and the bottom equation by 3. And you'll see these are both positive. So in order to cancel out, one of these has to be negative, and I'm going to choose the negative 3. So distribute that out, and I get 300 juice plus 75 water equals 1,575, and I get negative 144 juice minus 75 water equals negative 873. And I'm going to add these two equations together now because I know my waters are going to cancel out. And that gives me 156 juice boxes, or 156 juice cases, equal to $702. Okay, so then I'm just going to divide by 156. And the juice boxes cost $4.50 each. And since that's the only variable they asked me to find, that's all the work I need to do for it. I don't have to go back and find the water. So if they're asking for one variable, you need to eliminate the other. So that will help save you some work. Okay, number 9, a second-run movie theater charges $4 for an adult and $2 for a child. One night, 380 tickets were sold for a total of $1,320. How many children attended the movie that night? Whenever you have money here, you want to keep the money parts together. So that means $4 for an adult and $2 for a child. And they made $1,320. Now, about the 380 tickets, well, what type of tickets did they sell? Well, they sold adult tickets and they sold children tickets, and those tickets added together were 380. Okay, now see how they're saying they want us to find the number of children. So that means I want to eliminate my A's. So I'm going to multiply that bottom equation by -4. So I get 4A plus 2C equals 1,320. And then I get, when I multiply through, -4A, -4C equals -1,520. And now I'm ready to add my two equations together. That eliminates A, and I get -2C left equals -200. And I'm going to divide by -2. And my C equals 100. So that means they sold 100 tickets to children. And I didn't have to find the adults. So whenever they ask for one variable, eliminate the other one. Okay, number 10, David emptied his pockets and found that he had 30 coins worth $4.90. He only had quarters and nickels. How many coins of each kind did David have? All right, so I'm going to use Q for quarters and N for nickels, and he had a total number of 30 coins. Then we get into the value. Well, we know quarters are worth 25 cents each, and nickels are worth 5 cents each. And that totaled $490 in his $4.90 in his pocket. Now again, if you don't want to work with decimals, you can multiply that by the largest place value, which is going to be the hundredths place. And I get my quarters plus nickels equal 30. And I get 25 quarters plus 5 nickels equals $490. Okay, I'm going to go ahead and eliminate my nickels, so I'm going to multiply the top equation again by -5, and I'm multiplying by negative because I want them to add up to equal 0. So I get -5 quarters, -5 nickels equals -150, and I get 25 quarters plus 5 nickels equals 490. That didn't change. And now I'm ready to add my two equations together because I know my nickels are going to cancel out. So I get 20 quarters equals 340, and I'm going to divide by 20, and the number of quarters that I have are 17. Well, there's 17 quarters and there's 30 coins altogether. 17 plus nickels equals 30, and you can probably do this one in your head. I'm going to go ahead and work it out. Subtract 17 from both sides, and I have 13 nickels. So we did have to find both variables here. We had 17 quarters and 13 nickels in his pocket.